Yo, CTM students, how's it going? What's up? This is lesson 13.6. Let's do this. Let's get right into it. Measures of dispersion, range, and standard deviation. Let's talk about those things to start. Use those extra examples in your book to help you out as we learn this stuff. So let's get into some vocabulary first of all. What is the title of this lesson? Measures of dispersion. 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 Can't say the word. What is going on? Measures of dispersion. There we go. What are those? Measures of dispersion. Those are used to indicate yesterday, or I guess that was yesterday for me. You might be watching this at a different time. But the lesson before, 13.5, we talked about measures of central tendency. And so those were more like average values. So we had averages, we had things of that nature. Dispersion, how far is it spread out instead? So used to indicate the spread of data. How far apart is it spread out? So that's the big word there, the important part. Dispersion, how far is it spread out? The spread of the data. Range is one measure of dispersion. The range is always equal to, just think of what the word intuitively means. I hope this would be intuitive for you. How far do the values, how far are they apart from each other? The highest to the lowest value. That's exactly how we find it. So take the highest value and subtract the lowest value from it. So range equals highest value minus the lowest value. And finally, the big kahuna for this lesson, one that's much more difficult to figure out, but I don't know if I want to say that. Much more tedious to figure out. That's probably the better way to say it. It's pretty basic math, pretty basic arithmetic and stuff you learned before, algebra even, but it is a little tedious, I'll be honest with you. Standard deviation, we call that or we label that with a lowercase s generally. Sometimes you'll see this symbol, don't draw this one, but sometimes you'll see a lowercase sigma instead. If you see that, that generally is referring to the standard deviation of an entire population, whereas the lowercase s is referring to the standard deviation of a sample that you've taken. And so we're going to generally use the lowercase s, not this, not the lowercase sigma, but they're both standing for standard deviation. This is the one we'll use most of the time though, and so it equals this. It's the square root. It's going to look really crazy at first, but just bear with me a moment. So it's the square root of this, remember, means the sum. So we learned that in the previous lessons when we talked about the sum of the values, and this is the sum of the difference in the data values minus the mean values squared. So it's the sum of the squares of the data minus mean values over n minus 1. Let's draw off to the side, take out a different color at this point. I want you to take that out. This is actually uppercase sigma. I just learned that in this lesson. This is uppercase sigma, this is lowercase sigma. Just like we have uppercase and lowercase letters, so did the Greeks. I knew the Greeks had uppercase and lowercase letters, but I forgot that that one was sigma as well as this one. So right here, what this represents, this is the sum. This is in a different color now. Sum of the squares of the data minus the mean values. And so we're going to be using some tables to generate these numbers, to figure out these numbers in a little while. This right here, this n, represents the number of pieces of data that you have. So the number of pieces of data that you have is that number n right there. Number of pieces of data. And so let's go back to our normal color now and check out one of two examples. I'm going to do two examples where with each set of data we have, we're going to find the range and the standard deviation. So find the range, and if you want to abbreviate standard deviation like this, I'm fine with that. I'm going to be doing that for the rest of this lesson. So find the range and standard deviation for this set of data. And here's our data: 31, 8, 16, 19, and another 16. I'm going to keep it relatively small here, just a set of 5 pieces of data, so that we can focus more on the process rather than seeing how tedious we can make this. If we had 20 pieces of data, this would take a really long time. That's why we have computers for things like that, to do the computations, the tedious computations for us. But we need to learn the process at least before we would start to use those. So I want you to appreciate what the computers, what the calculators are doing for you. Range, take the highest value minus the lowest value. So in order, we would have the highest would be 31, the lowest would be 8. So 31 minus 8, that is 23. You're serious, Mr. Wagner? You're boxing that in? That's all we have to do for the range? Yeah, that's all you have to do. That's all it is. It's the highest value minus the lowest value. So the range, not very difficult at all to figure that out. But now to the standard deviation. This one takes some time. So to find, if you're going to calculate it by hand rather than using a computer or fancy calculator to do this for you. So to find the standard deviation, we need to learn how to do this process. First, we must, well, if we look at the equation for it, it includes this mean value. So we have to actually find what the mean is, and then we take each piece of data, subtract the mean from it, and then we're going to be squaring that. I need to know what the sum of all those values is. So that's where our table will come in. We must first, though, find or calculate the mean. So we have to know what that is first. We must first calculate the mean. So what is the mean? X bar is how we write that. The mean is 8 plus, I'm going to put them in order from lowest to highest, from least to greatest. So 8, 2 16s, a 19, and a 31. Do I have to put them in order, finding the mean? No, but I'm just doing that to make it easier later to see how it flows, or if I had to calculate the median, it would be really easy to do from that. We're not going to do that here in this lesson. We did that in the previous lesson. Could we calculate the median, the mid-range, the mode, and what's the one I'm forgetting? The median, mid-range, mode, and mean. That's what we're calculating actually right now. So yeah, we could calculate all those other things too. If you add these all up, you should get 90, and 90 divided by 5 ends up being a nice clean whole number, 18. And so this number we're going to take, plug it in into our table values in a little bit. So from here, let's write this down. From here, create a table. As shown below. So let's show that table below. What's our table going to look like? Let's make this table with 3 columns. First one kind of skinny. And then the other 2 are a little bigger. So about like that. Give each column a heading here. This is going to be just my plain old data. Here it's going to be the data value individually minus the mean value. So the data minus the mean, and over here will be the data minus the mean value squared. And so this is the tedious part of the standard deviation. It's not hard to do the math at all. It just takes some time. So the mean, that's going to be plugging in right here. Use a different color, point to that for me right there. This is going in right here. We calculated the mean value. The data values, I've got them all right here. I put them in order. And so I'm going to put them in order right down here too. 19 and 31. And you've got the blue lines on your paper just to make it as clear as I can. I'll add some yellow lines in here so you can see how it lines up. Alright. So the data value minus the mean value. I'm going to do some work here. You could do this in your head. It wouldn't be that hard to do in your head, I don't think. But if you show the work, then it's more easy to catch a mistake. It's easier to catch a mistake if you make a mistake. So 8 is the data value, minus 18 is the mean value. That data minus mean value is negative 10. Do the same thing with other numbers. 16 minus 18, that's negative 2. Another 16 minus 18 is also negative 2. 19 minus 18, that's 1. And 31 minus 18 equals 13. Now before you move on to this part, I highly recommend that you do this right here. I want you to add these up and see what you get. So negative 10, negative 2, negative 2, that's negative 14. And then 1 and 13 would be positive 14. And like it should, it adds up to 0. So let's make a little notation about this. I want you to write this off to the side. I'm kind of crunched for space here, so I'm going to write this a little small. But this, or these values should always add to 0. So these values should always add to 0. Make that comment right there about that. So over here, these were our data values. Let's circle those in the normal color. These were our data values. These were very important numbers. This is just the work. These are important numbers from this column. That's what we're most concerned about, is those values. And then from there, I want you to take those values, the data minus mean values, and square them. So we're going to take negative 10, square it. We're going to take negative 2, square it, and so on. Negative 2 squared again, 1 squared, and 13 squared. What do these values equal? Negative 10 squared, that is 100. Negative 2 squared is positive 4. Negative times a negative, remember, is a positive. We've got 4 again, we've got 1, and we've got 169. If we add these all together, this is the sum of the data minus mean values squared. Interesting, there's that part. That's this whole circled red part, the sum of the data minus mean values squared. So this is the most important number right here. Down here is the most important number from this whole table. This is what we're trying to get at the very end. But we had to do all this work to get there. So if we add all these up, we're going to end up getting 278. So that's the big number, the most important number. Let's make a comment off to the side about that one. So this, let's take a different color, make a comment, very important comment here. This is the sum of squares of the data minus mean values. Or in other words, it's this part. It's the sigma, and then in parentheses, x minus x bar squared part. It's that part right there. So what are we going to do now that we have that? I'm going to need another page here. Okay, and let's finish the problem up. So now let's use our getting fancy, Mr. Wagner. Very nice. Thank you. Therefore, remember that symbol from a while back? Brought it back like a ghost from the past. Sigma. I want to get practice writing this whole thing a couple more times, so we're going to write it out before we plug in the numbers. Later on, you can just plug in the numbers, but we're going to write it out again. So this was the sum of the data minus mean values squared over the n minus 1 part. And so this is going to equal, if we take our number from back here, that was 278. So that's where this number comes in. Let's do this. I ran out of room, but I want you to draw another arrow, and this one, pretend it continues on to this next page. So it's coming down here, and then I want you to go right in there. So yours is probably on the same page. That's where that value came from, the 278. That gets plugged in right into there, and we've got 5 minus 1. One more little note I want you to make about this. I want you to have really good notes later to look at. This is 5 pieces of data right here. 5 pieces of data. That's why that is a 5. And so let's work this out now. This is going to be 278 over 4. And that's the same thing. If I take 278 and divide it by 4, that's 69.5. And the square root of 69.5, plugging that into a calculator, gives me this number, 8.34. So this is a measure of the spread of the data. 8.34 is the standard deviation of this set of data right here. And let's box that in. That's our final answer. And I want to do one more so you can hopefully get a really good grasp of what we're doing here. In case that first one you're kind of still a little fuzzy, we'll do one more example together. So same thing, same instructions to begin. Find the range and standard deviation for this set of data. And I'm going to throw a couple of twists into here, nothing too big, but some decimals. 9.1, 4.6, 7.7, 8.2, and also a couple of negative numbers, just to show you how we would deal with those. Because sometimes you might have some negative values in your set of data. Sometimes you might have decimals in your set of data. So just so we get some practice with that together as well. So 6 values here, 6 pieces of data. Let's figure out the range first. That should be easy peasy. Find the biggest value. It is 9.1. So 9.1 minus the smallest value, the lowest value would be this negative 2.3. So it's the highest minus the lowest. This would be 9.1 minus, putting this in parentheses so I remember to change that to a plus sign here. It's minus a negative, so that's the same thing as 9.1 plus 2.3, which would become 11.4. Okay, so this is my range. That was a piece of cake. But now, the slightly harder part, the more tedious part, is to find the standard deviation. Remember, first we have to find the mean. So the mean equals 9.1 plus 4.6 plus 7.7. Notice I didn't put these in order this time, and that's fine. I did put them in order before, and that was fine too. You just have to add them all up. This would be plus a negative and plus another negative. All this over 6. If we add all these top values together, I had done that before, I double checked. I think I want to triple check though, because if I get this wrong, that really messes everything else up. If I do one of these first steps wrong, it's going to just totally mess up everything else. And so, yeah, I'll just get out the calculator here, we'll check it together. 9.1 plus 4.6 plus 7.7 plus 8.2. The plus and negative is the same as saying minus, so I'm going to say minus 0.6 and minus 2.3. And that gives me, yep, just what I thought it was, 26.7. If I divide that by 6, I get 4.45. So this is the same thing as 4.45. Now that's going to be important for us as we continue this problem. Let's make a table now. Table with 3 columns, just like before. I'm going to leave a little bit of space down here for my standard deviation calculation in the end. And then my headings. I'll draw in some yellow lines. I'm going to have 6 pieces of data, so I'm going to need to make sure I have 6 spaces for this. 1, 2, 3 spaces, 4, 5, and then I've got the 6 underneath that. Okay, let's move that up a skosh. And here is my data values. Here's the data minus the mean. And then here's the data minus the mean squared. Okay, this value, I'm going to put these in order now. So I'm going to go from least to greatest, the most negative to the most positive. Negative 2.3 to negative 0.6 to 4.6 to 7.7 8.2, and 9.1. Do I have to put these in order? No, because we're taking the sum of all these values, so in the end you're just adding the 6 values together. But I think it's nice. It makes it easier to, or nicer to look at, in my opinion. A little easier to compare things with each other if they're in an orderly fashion. So we're taking this value right here. Let's circle that in red. Or mine is in red, whatever color you got, circle it in that color. Remember, that's going in right here. So the mean value, we're taking this, each value minus 4.45. So negative 0.6 minus 4.45. Is this work you would have to show? I would say no, but better to be safe than sorry, in my opinion. If you show the work, you make a mistake, it's easier to go back and fix that mistake. But this is not totally necessary to be showing this work when you're doing problems like this on your own. I want you to show it right now, though, as we go through stuff. And this would be all that. So if we add and subtract, if we subtract all these, we're going to get these values. We're going to get negative 6.75. And I did want to mention something here. I did not round this at all. This was an exact decimal. If you ended up rounding this, you're going to have some rounding error over here, and they might not add up to exactly 0. So it's best not to round at all, especially with standard deviation, if you can help it, until the very, very end. If you had to round it at the very, very end, okay. But best to leave stuff as exact numbers as much as possible when you're doing these calculations. This would be these values here, 3.75 and 4.65. And again, I want to emphasize that we make sure that this actually adds up to 0. I'm not going to write it yet until I check it. So I want to verify that. That is pretty important that we do that, because if we mess this part up, that's going to mess this part up, which is going to mess our standard deviation up. So being extra careful not to make mistakes in the beginning as we go through things here. Let's see what we've got here. So we're going to type in, we've got negative 6 points. Why is, oh yeah, okay. I think I can do that. I think it might work. Just, yeah, it would be fine to do 0 minus 6.75 would be the same as negative 6.75. So I don't have a problem with that. 5.05. Now plus 0.15 plus 3.25 plus 3.75 and plus 4.65. Does it give me 0? Yes, it does. And so now I can move on a lot more confidently, knowing that these values added up to 0, like they should. So this is my data. Let's circle that part. This is the most important numbers here in that column. These are the most important numbers in this column. The rest is just the work. And then from there, we're taking each one of these values and squaring it and seeing what we're getting. This is that, this is that, and so on and so forth, continuing the pattern. It keeps going ad nauseum. How many different ways can I say? Just keep doing the same thing. The pattern continues. Okay, so we've got this. You square that, you're going to get a number with 4 decimal places. I'm going to include all of those decimal places because I want as an exact of an answer as I can get. So 45.5625. This squared is 25.5025. This next one is 0.0225. I just typed these values into a calculator to be getting this. I'm not that good at mental math. I feel like I'm pretty decent at mental math, but this is a little beyond my mental math prowess. 3.75 squared, that would be 14.0625. And yeah, if you're doing stuff like this in your head, I'd say you're like Charlie from numbers. That's pretty amazing. Boom, right there. So we've got all these values. Now I want to take the sum of these values. That's the top part of the standard deviation fraction. And if we add all these together, I did that before, I got 117.335. Now where does this value go? Now we're calculating standard deviation. Let's get that practice of writing this one more time. What is this? It's the sum of the data minus mean values squared over n minus 1. And the sum of these values, that's where this number comes into play. That's why we did all this work to get to this number. This number is 117.335. And this is going to be over 6 minus 1. And so from there, let's take this value, circle that, show that that got plugged in right here. This would be the same thing as, same number, 117.335 over 5 now. And then be careful, if you type this into a calculator, I want to show you a common error that I see, and then we'll comment on what you can do to make sure you don't make that error as you do this. So I would see some people take the square root of, they would type in 117.335, and I don't think mine shows it up like this, but they'd take the square root of this, and they would just put that in their calculator and say that divided by, they take the square root of that first, unknowingly take the square root of that first, and then divide that by 5. That is not the correct thing to do. That would give you 2.166. The correct thing to do first is to take 117.335, divide it by 5, and then take the square root of that number. So the square root of that number, 4.84, approximately. And so this should be approximately, let's change that sign to approximately 4.84. How can you guarantee, if you're typing this all in at once into a calculator, notice I kind of just skip from this step to this step. How can you guarantee that happens? Put this in parentheses. There's like invisible parentheses underneath any square root, and so think of it like that. Let's draw that in, the invisible parentheses. Let's actually draw those in a different color on yours. And so that is what we get. That is our final answer. Let's box that in. And so 4.84 is the standard deviation. We're going to talk a little bit more about what that actually means and how that's important in further lessons. That is my plan to talk about that. We're going to talk about normal curves in the next lesson, 13.7, and we're going to finish up with some linear regression, linear correlation with 12.8. But for right now, the important part is knowing how to do it, and then in the next lesson, we'll learn more about why it's important in the first place. Okay, hope that went well for you. Let me know in class if you had any questions.